The Earth's atmosphere. The Earth is 4,600 billion years old. Over the first billion years, there was intense volcanic activity that released gases to form the atmosphere. One of these gases was water vapor. As the Earth cooled, the water vapor condensed to form oceans. Volcanoes also released a lot of carbon dioxide, which means the air consisted of mainly carbon dioxide with little or no oxygen. The Earth's atmosphere then was similar to Mars and Venus. Volcanoes also released nitrogen, which gradually built up in the atmosphere. Volcanoes also release small amounts of methane and ammonia. When the water vapor condensed to form oceans, some of the carbon dioxide dissolved in the oceans to form weak acid, which reacted with minerals in the sea to form precipitates. Over time, it formed sediments of carbonate rock on the seabed. Some of the carbon dioxide in the sea was used to make corals and shells of organisms such as mussels. When these died, they formed sedimentary rock limestone, which removed carbon dioxide from the atmosphere. 2.7 billion years ago, photosynthetic algae evolved into the oceans, which produced oxygen. Over the first billion years, plants evolved which gradually increased the amount of oxygen. Now, the atmosphere is filled with 78% of nitrogen, 21% of oxygen, and the remaining is small proportions of other gases such as carbon dioxide, water vapor, and noble gases such as argon. The Earth's magnetic field. The magnetic field created by the molten metal below the crust churned as the Earth rotated, inducing a magnetic field. Gases from the active volcanoes pumped gas into space. They built up into thick atmospheres, creating the air pressure for liquid water to run on the surface for over 100 million years. This allowed Earth and Mars to have warm, wet paradises primed for life to take off. Mars also used to have a similar atmosphere as Earth, but when Mars's magnetic protection disappeared, the solar wind blew its atmosphere into space and its oceans boiled away, leaving the dry, sterile red rock we see today. If Earth didn't have a magnetic field, liquid water wouldn't exist on Earth and we would be in the situation as Mars. If there isn't an atmosphere, all the water would be boiled away despite really low temperatures. The troposphere. The troposphere spans 13 miles up from the surface, 7 kilometers at the poles, and 17 kilometers at the equator. This part of the atmosphere is more dense. The temperatures are from 17 degrees Celsius to minus 52 degrees Celsius. We see snow, wind, and rain in this layer. Weather occurs in this zone when water evaporates. 99% of the atmosphere's water in this layer, so most clouds appear here. Vapor contributes to the greenhouse effect and traps heat, allowing temperatures to rise and fall. As you go up into the troposphere, the air gets colder. Hot air balloons fly here too. The stratosphere. The stratosphere spans up from the troposphere for 31 miles, which is 50 kilometers. This part is dry and less dense compared to the troposphere. The temperatures in this region increases gradually up to minus 3 degrees due to the absorption of ultraviolet radiation. This layer contains 20% of the Earth's gases. Aeroplanes also fly here. The ozone layer is located here and it protects us from the rays of sunlight. The top of this layer is very hot because the ozone layer reflects the rays of sun back into space, which generates a lot of heat. In the 1960s and 70s, we were producing a huge amount of CFCs. All that went into the atmosphere and was hit by the UV radiation, which kicked off a chlorine atom and binded it into an oxygen atom. This caused holes in the ozone layer. There is one right here and over in Antarctica. If we do not have a protective ozone layer, it could cause an increase in cancer and damage to crops. The mesosphere extends 53 miles, which is 85 kilometers up from the stratosphere. It is very cold in this layer. In this layer, the temperatures are minus 100 degrees Celsius, 130 degrees Fahrenheit. Meteors burn up in this zone, and the temperatures fall to minus 93 degrees as you increase in altitude. The chemicals are in an excited state as they absorb energy from the sun. The thermosphere. The thermosphere This layer spans from 372 miles, which is 600 kilometers. The temperatures go up as you increase altitude due to the sun's energy. This layer is the hottest layer, which reaches up to about 500 to 2000 degrees Celsius. This is because the air in the thermosphere consumes lots of solar radiation. Most of the UV radiation from the sun are absorbed in this layer. The aurora occurs in the thermosphere, and the International Space Station orbits in this layer. The exosphere. The exosphere is the last layer of the atmosphere. It starts at the thermosphere and spans approximately 500 kilometers, which is 311 miles up. It doesn't really have a sharp end and just thins out into space or in planetary gases. The temperature varies in this layer. In the night it is freezing cold, while in the day it is extremely hot. In this region, hydrogen and helium are prime components and are only present at extremely low densities. Thank you for watching.